So in this blog, we would like to talk about a software that we made. It's called H.U.R.B.A.N Selector. We will speak about it quite a bit, but if you are interested in more information, we made a podcast specifically about this software tool. I will post a link to that podcast into the chat and also as a comment to the video. And also when it's then on YouTube, you will have a link there as well. It's like 2 hours, us speaking about more or less the same topic, but with different content, I believe. So what is H.U.R.B.A.N Selector? It's a software that the Slovak Design Center wanted to produce for designers. And the idea behind this that it's something that for people working in computational design is kind of natural, but obviously, just like in architecture, only a small amount of people works in the paradigm of computational design. The same applies for designers. So the idea comes from Maroš Schmidt, who is a Slovak designer, and also he's the director of the Museum of Design. And he's very active in all sorts of automotive design projects. And he's also promoting design a lot. So whenever I switch on the TV and whenever there's something about design, he is the one speaking about that. So he knows a lot, he understands a lot, and he's got a couple of projects that he runs on his own projects. One of them is that he is discovering unbuilt designs of cars that were designed either in Slovakia or Czech Republic, mainly in Slovakia. There is a brand of cars called Tatra that I think doesn't produce cars anymore, but it was very innovative back in its time. And it was one of the first car companies, or even maybe the first one that built an aerodynamic car, which looks completely awesome. Also, they were using, the question was if I mean Tata. No, it's Tatra with an R as the second to the last letter. I will show you. I also know the car company Tata, but that's not it. I will share my screen. I will show you what cars were they producing, and I think it was the first company to build a self load-bearing chassis. And when it comes to the engine, they had a very innovative engine, and they also are producing the lorries. But this is the car that was the first aerodynamic car in the world, and it has like a fin at the back. So maybe I can look it up. You see, it looks something like this, and it was in time when the cars they looked completely different than this. Where is this thing? Yeah. It's awesome. Also technologically, this was incredibly innovative, and basically every single car they produced, it had something special when it comes to technology, something that was first or new, except probably the last cars they produced in the 90s, and then they went bankrupt. But yeah, also the cars were incredibly luxurious at their time. So back to Maroš Schmidt, who his project is he's discovering unbuilt prototypes or designs of the car of these Tatra cars, and he found 2 designs. One from a designer who now lives in the US and is a senior, and one from another designer who doesn't live anymore. And they are basically, they proposed 2 new shapes for this Tatra car. And one of them is a coupe, which is a sports version of a car. I just, because of the zoom, I don't see this properly. So let me just, yep. So if you go to the website of the Slovak Design Center, you will certainly find the project about the Tatra cars. I will just try to look it up somewhere. So they took the design, the blueprints from the 60s, and they started to to produce prototypes and small models of the car, and also doing all sorts of promotion. And they wish to actually build a real prototype, working prototype of the car that would you be able to drive, and maybe then start producing it as a real thing. I'm just really looking for the car. Maybe I can look it up. So no, I cannot find it, but I will show you. I will show you the car later on, because there is the software that we made, because Maros wanted to find new forms mainly for automotive design, and he understands that that the human capacity and inspiration and invention and talent sometimes is not enough to create something that is truly new. And his idea of creating something that is truly new is a combination of existing forms. And he didn't really give it a proper name when he was describing his ambition. He was talking about some sort of a software that lets you select some versions of hybrid forms, that you just take 3 different examples or 5 and just create something that has features of all of these designs, and create something new that is unexpected, and then the designer selects out of possible versions one and works on that a little bit more. In other words, what he was saying in his words is exactly what I'm saying here for the whole week, and everybody at the Digital Futures. It's about the capacities of the computational design to actually create some sort of novelty, mainly thanks to the fact that you can create a lot of versions and select from that. So he was approaching different software companies with this idea, and all of them told him that it's a complicated process, and it's, well, he was turned down by many. And then there was, he told us, and we were thinking about it, and we realized this is something that we can do. We can produce a software that can do this for him. But at the same time, we were thinking like we can use Grasshopper or other tools, maybe Blender, to do that specific thing. And he wanted to have a standalone software. That was something that he knew. But at the same time, we thought, okay, if we use an existing software, then we are limited with what it offers. We are not able to give anybody a tool that is just, here it is, just use it out of the box. And also, this was a great opportunity to do something that is a software that we made for our purposes as well, or how to we had an opportunity to show how we think that a parametric software should actually work. And we told him, we told to the design center that we can do it, but we also want to do something a little bit more. We want to show and promote the parametric design process to the designers, not only to the architects. And we know that some of them are using even Grasshopper, but it's not as big as Grasshopper is for architecture. So we started programming a new software from scratch. We were not using anything that already exists. We were using a programming language called Rust, which is something that it's a new, ambitious, and promising programming language that I personally find very hard to use. But then when you learn the language, it's incredibly useful because it's very safe, very fast, and you actually can create software that works most of the time. Unlike when you use some other programming languages, there are so many cases when it crashes or doesn't work. Here it does work, and it's really, really fast. And we started programming everything, including the rendering on the screen, so the viewport, everything. Not only like in Grasshopper that you are using the Rhino viewport, but we were doing all sorts of shading and stuff. Partly also the user interface. That is one thing that we used an existing library for, but the rest is something that we made ourselves. Maybe, Anchi, you could now speak about that a little bit more. I will stop sharing my screen. If you need to share yours, you can. If not, just you can speak.
Yeah, sure. I will share my screen eventually. But first I'd like to maybe reiterate like what the purpose of the software was, or what were the initial ideas that were driving us to build it. So first is, as Ján already said, is that we wanted a testbed to prototype algorithms for selecting shapes in between 2 or even more forms. And we wanted to research multiple approaches to that. We'll perhaps show one of those later today, or even soon. The other idea was that as we were discussing on the last interview, we really like the declarative functional approach to modeling geometry, and we wanted to try our own take at that. Is inspired not only by Grasshopper, but perhaps in some modeling tools, there's something called the construction history, which is automatically recorded for you as you model.
So we can also say that when David Rutten made Grasshopper, the very first version of Grasshopper was not called Grasshopper, it was called explicit history, which basically means that even when he was designing this tool, he was thinking of like a way of record a history of steps that you make when you are modeling. We are building on the same concept, but we are not the only ones. Also, David was not the first one. This concept has existed before.
Yeah, exactly. So this is like the question: what will happen if you could change the history of your modeling, and if you could go back in time and not have to redo everything? So with that said, I'll share my screen. Hopefully this works. Okay, you should be seeing the software and a simple box in there. Let me just hide this thing so I can see. Okay, I'll just very quickly go over. I'll just very quickly go over the UI and what you can see in there. So the most immediate thing you see that there's a scene rendered. We have a box in there. We can we can move around the scene. Yeah, pretty much that's all that it is. There's a options panel on the right where you can, I don't know, create some new projects, open, save. We'll probably get to all of that at some future point. But okay, so how did this box actually get on the screen? And this is where the idea of explicit construction history comes into play. Is that instead of selecting the box in some kind of a toolbar and clicking on the screen to create it, we actually first decided to create an explicit command, or the instruction, or the definition of the box first. So what we did is in here down there, this is a toolbar with various tools organized by category, and what you do is that you select some of these tools and add them in here into what we call the operation pipeline. So for now, for instance, now I add the box tool, and I can perhaps transform it visually somewhere, so I can move it and the box moves. I can rotate it in this axis. It's in degrees, so it takes a while. And scale it in some other dimension. And at the same time, I could just go back to the original box and change that somewhat. And then that change is preserved and recomputed throughout the rest of the construction history. So what you do is pretty much put these operations and stack them on top of each other. There's various kinds of input into them. So when we want to create the box, there's just the usual suspect parameters, like where do we want it and how it should be oriented in space and what the scale should be. But in here with the transfer operation, for instance, we choose the parameter, like what is the input that we want to transform. And in here, so far we only have the box, so it is available here for selection. It was automatically selected when I was clicking the transform. A rather important thing is that there's this checkbox here that runs or automatically synchronizes the definition on the left hand side and what's in the viewport. But that's actually not what needs to happen all the time. So I can untick this and, for instance, try to smoothen the mesh. There's a smoothing operation which we'll perhaps also describe later. And as you can see, the viewport is not changed yet. I pretty much need to change it explicitly, which I do by clicking run. And because this is a box, this is a correct result, but it's not that well defined for the box geometry. So let me just insert a sphere there. So let's do this and run. Okay, and now I should have a sphere which is smoother than the original. To see it better, I can display it with edges as well. So if I click transform, so that's fine. Okay, let's go relax, run. Okay, and here's the algorithm applied to the sphere. I can try some other algorithm as well. So there's we could smoothen in with the loop subdivision algorithm, which generates new geometry. Let's pick this number of iterations, run again. Anyway, so by default, the definition and the viewport are not synchronized. This is because sometimes the geometry gets really large, and as you edit the definition, you first want to edit it and then later preview what the values look like. But for simple geometries like these, it's completely okay to have them synchronized. And now, as I change the parameters in the definition, we can see that the viewport updates immediately. Yeah. And as I said earlier, we can always go back to the previous operation and update the number of parameter, or update the parameters of it, and it just automatically recomputes the rest. Okay, and then so this is the basis of the system, and in this system we wanted to implement multiple kinds of object morphing or hybridizations. So I'll just quickly load a project that already has something like that in it. So let me open.
I already have one. Maybe I can share my screen now, and I will just show the result, and you can continue explaining.
Yeah, sure.
I will just quickly share my screen.
Sure, I stopped sharing, and okay. I think it's the same one. So yeah.
I think so. So it's this one. I will. You can then speak again. I will just show. These are the two cars that I was talking about. This is the coupe, and this is another. What's that called? The sedan version. Well, in English, I think it's called estate or something. I don't know. Anyway, so these are two versions of the same car. None of them was actually built. I sent you a link to see the videos, the story about this one being restored or actually built for the first time. It was never built before. So now they are building it. It was designed sometime in the 60s. And this one as well is the same car, different shape. And now we can hybridize the form. So this is a car that is halfway between the two. You can see it on the roof line, for example. It's not this, it's not this. It's somewhere in between. And we can change the amount of like what it is. Let's make it 1/4 one of the car, 1/4, 3/4 the other one. So now it's 3/4 this car, 1/4 this car. You can also see it on the front. Oh, sorry, on the front a little bit, and we can then go the other way. So now it's going to be 3/4 this car, 1/4 this car. and so on. And then I will give the word back to you, and maybe I will load a different example.
Mm-hmm. Yes. So just quickly noting that there's actually different color themes for the editor, and once again, so what you're building is very similar to perhaps Grasshopper. The project that you have isn't the models that you import or something. The project is just a definition, and you can share the definition with someone else, and they can plug in their own models and make. And you pretty much share your small tool that you made this way. I believe that this is a very similar philosophy than what you use with Grasshopper as well. Okay,
I can also add the fact that we didn't really focus too much on the user interface, but mainly on the engine. And the user interface can be changed slightly. And the main idea is that if you are used to modeling in a 3D software that is not parametric, like 3ds Max or something else, then eventually we would like to have a user interface that allows you to do all sorts of commands like move, transform, scale, or do some sort of modeling in place. But at the same time, it will be creating for you the parametric model just like a Grasshopper model. So the main idea is that you will actually build a Grasshopper model without working in Grasshopper, and then you can open it and tweak it. I will share my screen one more time. Mm-hmm. Maybe I can show you how does it work now. And well, the user interface is still kind of clumsy. It's still, I wouldn't say it's bad, but it doesn't do what I'm saying, but it does all the other things. But the engine is completely ready. Like the core of the software is ready to do what I described. So here we've got a lot of commands. This is actually a beginning of the tutorial part of this block. Is there anything else you would like to add before I start with that?
Yeah, just perhaps as you already said, that we really didn't spend much time on the user interface. That this project is pretty much still very experimental, but we do intend to continue developing it. And I'm not sure we mentioned this, but it is completely open source and available on GitHub, and we should perhaps share the link somewhere.
Yeah, please share the GitHub link. I shared the link to download the software. Mm-hmm. The thing is that it's not that, I wouldn't really say that we didn't really focus. Yeah, we didn't focus on the user interface because it is experimental and we didn't know what the user interface should be. And we are still exploring this. Because one option is that it will actually really build a graph like node-based wires and stuff like so that it looks like Grasshopper. That's one option. Another option is that we just try to keep it as much close to usual modeling softwares. So we have buttons and tools and maybe a structure of a hierarchy of geometry, just like Cinema 4D, for example. Then there is something like modifiers in 3ds Max, which basically does the same thing, but it records some sort of history, but it's out of the system. So you apply the modifiers on certain geometry, but still you have most of the options outside of these modifiers. And then there is another option that we can have some sort of a timeline that actually tells you at this time you were doing this, and you can return to that time and actually change anything that you made at that time, and it will recalculate the rest of the definition. So we're now thinking of the options. The reason why we have two color themes, color themes, is that this one that I'm using, the light one that you saw before, it's synchronized with the style of the Slovak Design Center department that is called InnoLab. InnoLab stands for Innovation Laboratory, where they have a library of materials, where they have a library of tools, and they also have a library of forms. So they collected 1,000 3D models that are original works of either designers or students of design, or actually of I'm sorry, somebody is touring a car here. Designs of objects that they 3D scanned and gave us, because these 3D scanned objects they are building up a library of design that was over time made in the country. So that's why mine is light, because it's in sync with the InnoLab identity, and the dark version is something that is more geeky, and maybe it's a bit more ergonomic as well. So we've got two options here also. Let me show you now how to hybridize two simple forms, and I'll just guide you through this a little bit more. So we didn't put together a manual to this software, but when you install it, wherever you hover your mouse, there's a lot of explanation about what the tools are actually doing, and if you click any of these buttons, it even, well, you know what happens. We were also trying to explain in detail what is the logic behind. So we are somehow explaining also the technicalities behind. So if you read this, it actually gives you a pretty good idea of what is happening behind. So, some of these tools are creating very simple geometry like plane, box, sphere, and so on. But some are importing existing objects. That's what I'm going to do. So you see that this added one operation to a pipeline for me. It is equivalent of you putting a component into Grasshopper. So I added this operation here, is the first one, and it requires me to specify which file do I want to open. So let's open the Tatra car. So like this, I can reset viewport so that we see it better. It's this car. You see that Ján actually made the rendering really nice. It looks very cool. We can change the way we see the stuff. This is wireframe. This is wireframe and shaded. And there's also X-ray so that you can see through the model while being actually shaded. So now we can do a lot of stuff with this model. Also, one more thing, just like with Grasshopper, it sometimes can send you messages that something went wrong or something went right. We have a little panel here that tells you if the operation was fine, if it completed well, and it gives you some more information if you want so. And if there is an error, it tells you. And first, I added the operation here without setting the parameters. Just like in Grasshopper, when it's orange or red, there is an error. We also had an error because I didn't specify which file to open, and this is a historical record of something going wrong, and it also tells you that the file was not found, so we are informing a lot. So if I click here, the mesh analysis, I hope it's not way too slow. It can be really slow. So if I click it, it actually tells me a lot of information about the mesh model. You see that now it takes some time, but anyway, it gives me a lot of information. So for example, it tells me what is the bounding box size, where is the center of the model, what is the diagonal length of the bounding box, which basically tells me in which scale the model is, which is kind of important if you want to know if you should move it 10 or 1,000 units. So I know that the diagonal is 500 something, so that's more or less the scale of the model. It tells me that it's a triangulated mesh, which is true. If you look here, it's triangulated. Then it tells me how many vertices, that means the points. It has how many normals, how many faces. So basically it runs analysis on the mesh. It tells me if it's a valid mesh. So it tells me if there are some orphans, which means unused data. There is not, but it also tells me it's not watertight, which means that it's not welded. It is manifold, which means that it's valid. It's orientable, which means that all the normals are going either inwards or outwards. So it tells me that it has some non-deterministic, potentially invalid naked borders, border loops. That's actually kind of strange. No. It actually is okay. It can happen like that. And it eventually told me how long did it take. So it took 2.3 seconds to calculate all this data. Maybe next time I run this, it will be much faster. But you see that we took a lot of effort to actually inform everybody because we really want this to be a tool that makes you understand how does the parametric modeling actually work. So if you want, you can see this information. If not, then you don't have to see it. And then I can do something with this model. For example, I can transform it. So I've added a new operation here, which is called transformation, which basically is moving, rotating, and scaling in one operation. And I will show you one more thing here. I know that this is like 500 units, so if I move it about 100 units in the, I think, Y direction, it could actually work well. So now it's moved 100 units to the left. Actually, can you hear the noise? Is it disturbing?
A bit, yes.
Yeah, okay, I will close the window because somebody is just getting crazy with the car outside. All right, they were fixing a car in the street, which is okay. So I'm back. Sorry for that. So you see that now there is. I also have to say, how does it know that I want to move this geometry? I have to pick from a list of possible candidates to do something. And this is exactly like putting a wire in Grasshopper from one component to another. And here we only can, with wires, we can only connect geometry. So we can only use the wires for geometries, not for numbers, not for anything else. This is kind of intentional and kind of temporary because that makes it even easier to understand that you are basically making the functional transformations like mapping. We are mapping one geometry to another using certain function, and these functions are these. So for example, this function is transform, move the geometry from one place to another, and do it with all the elements of the geometry. The good thing here is that this is also immutable because we think this is very important, which means that the original geometry still exists. We call it used geometry, or I internally call it a zombie geometry. It's a geometry that has been used and maybe could disappear, but it didn't, and you can reuse it, and we can display it like this, and you see that the original car that was imported is still placed here, and I can still see and use it, but if I don't want to, if it's an obstacle for me, then I don't have to. So now I actually see that I didn't move it enough, so I will probably just move it, not 100, but 200 units, like this. And I see that it's not an obstacle anymore. So now they're one next to another. So I can show you now what does it mean to actually reuse geometry. I will place another transform here. And I will take this geometry and move it 200 units upwards. So now I'm moving, so this is something that you would do in 3ds Max, for example. You would import something, move it once, move it twice. And all the old versions, they would disappear. For us, they don't disappear. I will reset. And instead of moving this one, I can say that I want to move the one that was already used. So now this was used twice, and this was not used, so they are not zombies. So the logic was move this one here, and again, this one move here because it didn't disappear from the history, so it's still available. Good. So instead of doing this, I think I can do an experiment here, which I've never done, and maybe this it's surprising that I've never done it. So let's just move this original to 200 to the left and also 200 to the right. So we've got one here, one here. Okay, this wouldn't really work, but yeah, let's do it. Like this and like this. So now it's here. And also, let's rotate it around the z-axis. So it's here, and let's rotate it 180 degrees. So now one is facing forwards, one is facing backwards. And we can try to hybridize actually these two versions, like this car and this car, and we can make a hybrid of the same car facing forwards and facing backwards. Hybridizing is another tool that we have here. We add it to the chain, to the pipeline of commands. Also, well, I forgot, were you speaking about the voxels and scalar fields?
I didn't mention concretely what the algorithms for hybridization were, so no.
So now, because when I want to hybridize two forms, they somehow need to overlap, otherwise it wouldn't work. So there is a component for that that is called, how is it called? Is it match or is it plane transform? Align. It's align. So I can take the result of this operation and the result of this to actually match. So I will try to match these two and run. And it basically puts them one over another. So you see that it actually placed one over another. Both of them are used, and there is a result. But now I'm thinking this is probably not what we wanted to have, so I will remove this one. The thing is that they need to be at the same location. So I already have, let's place them in the middle. So I already have this one here, and I also need to copy it and rotate it just like this. So this one and this one will be here only for the purposes so that we actually see how does it look. So I will just use, for hybridization, I will use the original one and a rotated version. So I will take transform one more time, and one more time I will use the same model from here. So it's the imported mesh, the first one, and I will only rotate it 180 degrees. So now the result of this operation and the result of the very first operation is the same car at the same place, just rotated 180 degrees. And now I can hybridize these two. So there is this thing called Voxel Morph. And I will take the first mesh and the last mesh, and it gives me an error. And the reason is that it can be actually very slow, the hybridization. So there is this checkbox that tells me it prevents unsafe settings. So it doesn't really calculate because it might be incredibly slow. And it recommends me to use bigger voxel sizes. I will return to the voxels very shortly. So it recommends to use something about 5 units voxel. So I will use 6 units to make sure that it actually performs well. So I will run this, and you see that it actually created some geometry for me. It doesn't really look so nice. So let's make it look much nicer. I will nevertheless use much smaller voxels. So if this is 6 units, let's make it 3 units big, and calculate and switch off prevent unsafe settings. So okay, now this looks slightly better, and even if it looks better, it's still very boxy. So I will apply a smoothing algorithm that is called relax, and I will relax the result, smoothen 20 times, which is quite a lot. Let's see the result. Yeah, and you see this is kind of smooth, and it lacks a lot of detail. So I will even make this number smaller. From 3 units, I will make it 1.5 units in size, 1.5. Now the calculation will be a little bit slower, but still it's pretty quick in comparison, for example, to doing the same thing in Grasshopper. That would take ages. Okay, so this was way too small. We are losing a lot of detail here, or maybe we've got an error, I don't know. I need to have a better look. But let's try one more time with different settings. Okay, this looks okay to me. And you see that this is a hybrid form that is halfway between this car and this car. You see, and we can, and now you see that there is a chain of operations, and I can change anything in the history of the chain, and it still recomputes everything after. So let's make it 75% one rotation, 25% the other one, and let's see what does it look. Yeah, so it's 75% this car and 25% this car. So I will save this one, and I will go one more time and show you. Actually, I don't have to. No, I don't have to start from scratch. I can say, well, still, it's a good idea to save. Okay. At this point, I can show you that, well, you can export the result as an OBJ and open it in other software and edit, or you can save a screenshot, which is a high resolution transparent PNG file. So I will take a screenshot, it saves the screenshot for me. I can maybe open it just like this. It should be, yeah, and it looks, well, this is not it. I think it's this one. Still opening. Okay, I've opened it twice. Just let me do it one more time. So this is the file, so you can see, and we can save it in a much higher resolution. This is kind of a powerful computer, but even on less powerful computers, this is like a huge resolution, 11,000 pixels. So I can take a screenshot and hopefully, yeah, it does save the file, and we can have a look at the file, which is this one. There we go. And when I zoom in, it's oh, hold on. It's a very high resolution image. So it renders really nicely. So anyway, let me import one more file and hybridize this form to another file. And to do that, let's do it like this. Import. I need to specify what file do I want to import. And we were trying actually with a toy car before. First, let's do wireframe, run. It takes a while to import and to do all the operations because it actually recalculates everything all the time. And you see that there is a small toy car in the middle with a key like this, cute little car. And I want to hybridize this hybrid to this car. So first of all, I need to scale it up so that it actually matches the size of this model so that we can hybridize it well. Let's see if align, I forgot if align actually scales as well. So let's see. Yeah, it scaled everything down. So instead I will just switch the two. So let's scale it up. Okay, now it's scaled up. Because the hybrid has been already used, it became a ghost, a zombie. So I will, we can show it like this, but I see that the center of this car is somewhere here because it's got the key. So I also need to move the car a little. So I will transform the last geometry and I will move it to the right, like, I don't know, like this maybe, recalculate. It's too much, so maybe something like 40. Yes, now it matches nicely. And you see that it's shorter, but I will keep it shorter. It doesn't really matter so much. So now I can hybridize this toy car with the already existing hybrid, only because I want to see all of them at the same time. I will move this car one more time forward so that we actually can see all three of them, because when I use it, it will become a ghost or a zombie. So I will transform and move the car. I think let's do it like 300 units forwards. So that was backwards and 300 was not enough. So let's make a minus 500. Maybe that will be in front of everything. So it should be here. Okay, this looks good, but because nothing's got lost, only became a zombie, we can reuse everything one more time. So I will do Voxel Morph again. And I will Voxel Morph the result of this transform, which is transformed mesh number 9, which is one input, transformed mesh number 9. And the relaxed mesh, so it was the original one, which is this one. And this will create a hybrid for me, but also I need to set the voxels to have the right dimension. I will switch prevent off. I will add relax because I know that I want the result to be smooth, and 20 iterations sounds like a good idea. And I will switch off draw use geometry, and I will calculate now. It takes a while, but not too much. And now we've got a hybrid between the 3, 1, 2, and 3 cars. And you see this is halfway. Let's see what the hybrid, what we're rehybridizing here. So let's make it, now it's 75% this car, 25% this car, and that is being 50% of, like that hybrid is 50% of the result, and this is other 50%. So let's make it a little bit more this car. So I can change the proportion here, and I believe it's going to be the first one, so it has to be 75% the first car. So now it should be a little bit more the toy car. No, it's the other way around. So it's 75% a hybrid of these two, 25% a hybrid of this one. You see that there are some features you can observe, like the shape of this and this. Let's do it the other way around, so that's more the toy car rather than these two. Let's recalculate, and the result is this. And it's got all the features of, well, it has some features of this one, some features of this one, and some features of this one as well. Maybe I can change, the interesting thing is that I can change anything in the history. So because now the hybrid was more of the backwards car, I will make it more the forwards car, the first hybrid that we made. And maybe the result will be slightly nicer, something between this one, and a little bit this one. Okay, it looks a little bit more like a car, and let's make it 50%. Now, as Ján said, it's we are basically building up a tool with this. This is less a model, more a tool, and you can reuse the tool for other models as well. And let's just give it a very quick try. Now it's, yeah, I made it halfway between this and the hybrid of these. So you see that you can see features of both. It's got the roof line of this one, slightly of this one. It's got the wings here of this one, and it also has something from this one as well. So I will save this as something like this. And just as an experiment, I will replace this car with a different model, because basically we already have a tool that allows us to do that. So instead of loading this toy car, I will load something else. And we can try to, we can have like a kettle. Let's see. I don't know how does the kettle actually look like. So instead of a car, we will use a kettle, and we will hybridize a car and a kettle. Okay, that's new.
Yeah, not great, but
not great, not terrible. No, I think it's actually kind of great, because this is, again, this is a shape that you wouldn't come up with yourself, but yeah, it gives certain idea how a love child of a car and of two cars and a kettle could look like. The good thing is that if you prepare your models properly, then you can hybridize in like crazy ways. Okay, I think that should be enough about H.U.R.B.A.N Selector. It's available for download. We are still developing it a little bit further. We are also looking for some more funding to actually turn this into something a little bit bigger. The good thing is that we already have the engine that does a lot of geometry processing, and and I really love the system that it actually creates here. We might display it slightly different, but the system is amazing. There's a couple of things that are really good when it comes to the way it was designed by you. One is that you don't really need to execute at all. You can just build it up blindly and then just calculate the result with whatever input you have. Also, I have to say that most of the hybridizing algorithms are based on voxel geometry, or in other words, in scalar fields, in fields of information in space, which is super useful and a great way of doing things. I just realized because we originally wanted to use more. So using voxels is like a brute force approach, and we were first thinking of using a very detailed and specifically suitable algorithms for mesh geometry, but instead we somehow started using voxels and scalar fields because they allow so much more things, and the data processing there is incredibly efficient. So we can turn everything into a voxelized model, then do something about the data, and there is a result. And we've learned a lot about voxels here. And also, not only that we have a software that does something that looks okay, we've learned programming, but also we realized that using voxels and scalar fields and clouds of information is a great tool for producing something. And in fact, we are now going to start a research project that I mentioned before at Subdigital. We've got interns, and we have built a team. By the way, still you can somehow apply for the team if you feel like. That would be awesome. And within that period of the research, we are going to work on a project that strongly builds on the experience that we got that we got here, and that we learned about the scalar fields, about voxelization, about adding discrete units one to another. The question is, whether you can apply for the internship? Yeah, sure, you can. Within the European Union, you can get an Erasmus support, and that is also a very beneficial thing. So of course, you can apply, and we can discuss if what can be the thing that you would be doing here and under what conditions. Janši, do you want to add something?
Thinking, yeah, only regarding to the software, one thing we are actually considering is also moving to the node-based UI, just because you can lay it out in space better and organize it a bit more with clarity.
But I think it's questionable, or like, yeah, there are more options.
We need to try multiple things out.
Yeah. It has to be an experimental approach all the time. That's why we are doing it. So I'm also checking Facebook. If anybody is asking something, please, if you feel like asking or adding or commenting, just do so, please.
Yeah, and also I just realized how to make it much faster.
You did?
Mm-hmm. Just now, but
okay. So this was very useful.
I'll tell you later.
But the thing is that it already is very fast, because the amount of data it is processing, if we were using it as a plugin for Rhino or for Grasshopper, it would be way slower. So it already is very fast, and we haven't done much of an optimization yet, although there is some. So there is no parallel computing, which we can, I would say, easily implement, but we didn't because we didn't know how, or like we didn't decide which way to go. But even if we wanted to make this faster, it wouldn't take too much effort, and we could make it maybe 5 times faster or so. Depends on the number of cores you have, and so on.
And the structure of the program depends whether it branches a lot or it's just a linear chain of operations.
And those operations can be parallel, just like Grasshopper is doing. So,
yes.
But that's a technicality. And even as a prototype, I think it's impressively fast, I would say. And that's only thanks to the use of Rust, and thanks to you that you have insisted on the right way of writing the code. And it also matters a lot. We managed to speed up certain operations like hundreds of thousands of times just by writing it in the correct way. I know that because I wrote it in the wrong way, and then you came and fixed it, and it was 100,000 times faster.
Yeah. On the other hand, sometimes the optimizations made like 5% boost, so it's not always that you still have to measure to be sure. Yeah.
But that's something that I wouldn't be able to do without you. Like this wouldn't be possible without you at all. We have to say that you were the project leader, and there was another person working on that, Ondrej Slintak. you were responsible for the overall architecture, and you were leading the course of the development, and I was basically just doing the mathematical and geometrical operations, some of them, and I was also the one who was causing all the mess because I'm not a programmer, and I just was doing things in a wrong way, and then we spent a lot of time fixing my mistakes.
But at the same time, you were bringing a lot of ideas. So you were the idea generator.
See, and then there was Maro Schmidt, whose idea it was at the very beginning. So, yeah, a beautiful synergy.
Indeed.
All right. If there is no questions or comments, you can still switch on your microphone and talk to us. That's okay. I will just say a couple of words about what is coming up. We are filling up the list of people whom I'm going to call tomorrow. So tomorrow there will be a morning session. We will finish at 12:30 my time. It's almost 1:30 my time here. So whatever time it is for you. So it will be just the first morning session, and we will call a couple of interesting people. I will announce that by the end of the day. But still today at 5 p.m., which is help me now. It's like 3.5 hours from now. Yep, 3.5 hours from now, we will have a short call with Anouk Wipprecht, who is an amazing fashion designer, and she's doing interactive robotic fashion that looks awesome. It's very related to what we do. It's really haute couture, and I'm very happy that she agreed to have the call with me. Actually, it happened really naturally because, well, of course, I've been following her work for many years. And I think she used to live in Vienna when I was there as well, but we never met and we never talked. But when we had the chat with Mike Pryor, she was watching us and she was commenting, and she liked what we were talking about. So I approached her and asked her to kindly join me for a similar talk, and she agreed. So I'm very excited about that. And that will be at 5 p.m. my time, so 3.5 hours from now. Whatever time it is for you. That will be half an hour, and I will try to make the most of a short conversation that we are going to have. And that will be it for today. And again, we'll meet here tomorrow at 9 a.m. and we'll talk to many interesting people. Most of them I've announced yesterday already, but we are filling up the list. So stay tuned. Still, one more time, any questions? Anything you would like to ask or say, or?
Should we talk about the project, the coming project, more detail now or tomorrow or anytime or when?
Which coming project? The research project that I announced?
Yeah, that one.
I don't know if we actually should talk about it at all. The thing is that we are basically starting the project on Monday after this conference is over, and we still need to think about it a little bit, and we'll start with a brainstorming session. But I can tell you what is it going to be about. I think I was showing the
so is it be going on online or like?
No, that will be not an online project, although I'm thinking that maybe we can involve some people who will contribute remotely, either with some calls and lectures and some reviews online. But just to give you a hint, we are going to build a system how to generate or aggregate discrete elements in a very, very sophisticated way. So what Manuel was showing 2 days ago, that's an incredible amount of effort and work, and we would like to get at least at this level or maybe beyond, and to be a little bit more universal. So we are going to build up a software that generates the discrete structures, but also the team will work on applications, case studies. The team will put together all sorts of input data and so on. So this is what will be going on. for 3 months here physically. But as I said, we will have some people contributing online, mostly as the reviews. And also, if this works well, to be realistic, I don't think that we can finish the whole thing in 3 months. So it seems, for me, it would be a great way of working that in each period of time we will have, like, maybe once a year, maybe once in 6 months, we will have some period where we will actually work on a research project in a setup where we invite interns and experts at the same time. The interns should contribute and also learn at the same time, and the experts should mostly contribute. So if this works out well, we are going to have more and more research projects like this. Also, because we somehow need a platform to develop our own long-term agenda as a studio, and also as an education and research platform.
Yeah, I got it. I would like to contribute, but I don't know how this will happen, because for now I live in Turkey, and my semester will start, I guess, in October in Germany. So till that time, I don't know how I can contribute, but I would like to keep in touch, like see.
Gladly. One option is that, well, let us think about it. Let us think about it, and maybe we can figure something out.
Yeah, sure. Thank you.
I'm very happy that you're interested. That's it means a lot.
It's my pleasure. Thank you so much.
Anyway, if that would be it,
and thank you so much for Ján also. Both of you.
Yeah, thanks. It was. I'm super excited to be here.
Very informative. Yeah, I learned a lot.
I always learn a lot when we talk to each other. It's awesome to have a true computer scientist sitting at the same office. So
yeah, true.
It's awesome.
I actually started to think like future actually is all about writing scripts and, like, you know, doing some computer stuff. It will be all technological, like, innovative thing. So it's good to know.
Yeah, it's good to know the principles, because maybe eventually you wouldn't have to write the code, but you will just use some other means of defining a code, just like Grasshopper, for example, is no code, but you can also do programming in all various different ways. But the principles, they will probably remain the same. I recognize these two main paradigms. One is imperative, one is functional. And when you know that, then whatever tools emerge, you probably would understand how to use them.
Yeah. Also, in general, it's kind of very useful to know how the tool works internally, at least a bit. So even if you use a tool and don't build it yourself, you can still see, this is what is happening on the background, and if I really needed it, I could do this on my own as well.
This is something that I was also discussing when we had the research day. It was the second day when I was explaining why do I prefer using vanilla Grasshopper with just as few plugins as possible, because then you really understand what is going on, because you're going low level. But then Mike had a good comment that when you are advanced and when you are sure that you understand what is happening, then why not using ready-made tools that save a lot of time to you? As long as you know how to use them and what are the limitations and edge cases, why not?
Yeah, seems logic.
Yeah, true.
Okay, thank you very much. Let's finish the stream and see you in 3.5 hours.